Hi there, everyone. Welcome back to another video from Unnati Academy. And this one is a very interesting question from a famous book called H C Verma, which we all follow for physics. And this one relates to projectile motion, and the situation here is very interesting. Now, there's a batsman who hits a sixer, and the ball goes all the way to the benches. Now, it says that the batsman hits the ball 1 meter above the ground. So let us say that the ground is here and it's 1 meter from here that the batsman hits the ball. And it goes at an angle of 53 degrees to the horizontal at a speed of 35 meters a second. And the ball travels like this, and the benches start here. The benches start here, right here, and the benches rise up like this, and the ball goes and hits one of the benches here, right? And we need to answer what is the bench that the ball goes and hits. And the benches go like 1 meter, 1 meter, 1 meter, 1 meter. So it's like a staircase. So if it's the fourth bench, let's say, that it hits, then it's going to be 4 meters horizontal and 4 meters up. And that's how the diagram is drawn as well. And this is the baseline from which we analyze the projectile motion. This actually is the ground. I'm going to mark these two here. Ground and baseline for analysis. Now, it's also given to us that the distance between the batsman and the stands is 110 meters. Now it gets very interesting at this point. We need to see which bench this is going and hitting. Let us say it hits the nth bench, right? N benches, right? So I can say that the horizontal distance that the projectile or the ball has covered is 110 meters up till here, plus another n meters, because each bench is n meters. So I can say that it's covered a horizontal distance of 110 plus x meters. Now we know that the horizontal velocity stays the same throughout the motion. So this horizontal distance is going to be equal to 35 cosine 53, which is the horizontal component of the ball's velocity, times t. And this t is the time to hit the bench. All right. All right. So we're clear until this point. We are hitting. All right. Sorry, I'm not going to use x. I'm going to use n because nth bench is what we've hit. So 110 plus n equals 35 cosine 53 times t. Now, what is the height of the projectile at this point? Now remember, the baseline has to be used is this line here. And this is how we analyze the height of the projectile. And this line is 1 meter above the ground. Now, this bench here, the bench that it hits, as you know, it's a staircase which goes 1 meter horizontally up and 1 meter vertically up with each stair. So if you've crossed n benches, you are at a height of n meters above the ground. But how high are you compared to the baseline? Compared to the baseline, you're going to be only n minus 1 meters because the baseline is 1 meter above the ground. That's an important point to note. So at this point, the height of the projectile is n minus 1 meters above the baseline. And that's equal to the vertical component, 35 sine 53, times t, the time to hit or reach this point, minus half gt squared, basically ut minus half gt squared. And I'm going to take g as 9.8 times t squared. Now this equation 1 and equation 2. Now it's easily solvable. We can substitute n in terms of t here and then just solve for t. So from equation 1, I have n equals 35 cosine 53 times t minus 110. And 35 cosine 53, if you do your calculations, is around about 21.1. So 21.1 times t minus 110. I substitute this into the second equation. So I'm going to get 21.1 times t minus 110 minus 1, basically n minus 1 here, equals 35 sine 53. Now, what is 35 sine 53? 35 sine 53, you would see, is very close to about 28. 28t minus 4.9 t square. Actually, let's quickly find out what is 35 sine 53. I'm not very sure if it's 27 or 28. So let's quickly do that. And (35 sine 53 degrees). All right, that is 28 indeed. And let's go back to our question. Right. So I'm going to use that as 28. And now reducing this to a proper quadratic form, bringing everything to the left-hand side, 4.9 t squared minus 28t plus 21.1 t minus 111 equals 0. And this is going to give me 4.9 t squared minus 6.9 t minus 111 equals 0. Now you can use a quadratic solver or solve it using your discriminant method, and you will probably get around 5.5 seconds. And now we can go back and substitute this here in equation 1 here. So 110 plus n equals 21.1 times 5.5. And you would see this is about 116. And from here, we can see n would be 116 minus 110, or 6. And hence, we can say that it's going to hit the 6th bench. And well, that was a very beautiful problem. And I hope you understood it and also tried it on your own. And if you have any doubts, please write in the comments, and you can also check out our interactive simulation on projectile motion. And we hope to come up with more such videos for you very soon. My name is Shakti. I did my BTech in Electrical Engineering from IIT Madras, and I love teaching physics and math. And signing off, take care. Bye.